Hello and welcome to the Unit 3, Section 3 video on discrete versus continuous functions. We're also going to be continuing on in domain and range and talking more about that as well. So let's start off by talking about discrete versus continuous functions. A discrete function is a graph whose points are not connected. So we have a set of ordered pairs as you see in this graph below. None of these points are connected, they're all independent, so we have a discrete relation. Then over here we talk about continuous. This is a graph whose points are connected. And so the result is a line that you can trace without picking up your pencil. So let's talk about domain and range. That's basically going to be what we talk about the rest of this section. And we're going to start with continuous functions. So for two endpoints, which means we have no arrows, first you're going to find the location of the two endpoints. Then you're going to use parentheses if the point is not included. Okay? So on the graph it will look like an open circle. We're going to use brackets if the point is included, and that would look like a closed circle or a solid line on a graph. You're always going to look for the points furthest left and right for the domain, because we're looking at x values for domain. And then you're always going to look for the highest, or let's actually start with lowest, the lowest and highest points for the range, because we're looking up and down because we're going along the y-axis. So let's do some examples. So for this first example, our values from left to right for our domain, 1, 2, 3, 4, 5, 6, 7. Our farthest left is -7. Our farthest right is 1, 2, 3, 4, 5. The -7 is included because it's a solid dot, so we use a bracket. And then the 5 is not included because it's an open dot, so we're going to close it off like that. For the range, we look from bottom to top. So 1, 2, 3, -3 on the y-axis. Going to 1 on the y-axis. We include the -3 because it's solid. We do not include the 1 because it's open. For the next example, the domain goes from -3 to 4. We include the -3 and we include the 4. The range goes from -2 to 4. And again, we do include both ends because there's a solid line here and here. All right, let's take a look at the next couple of examples. Here we have another square, another box. The domain goes from -4 to 4. And because we have a solid line on each side, we include it with a bracket. Here we're going from -3 to 5. And again, we are including our ends. For this one, our domain goes from -2 to 2. We do not include the -2 because both of those are open, but we do include the +2 on the top because the graph touches there. Our range goes from -2 to 2, but we don't include either because of the open dot on the top and the bottom. For the next example, our domain goes from -5 to 3. And we do not include either side because of the open dots. Our range goes from -3 up to 5. And these are included because we touch here and here. For this one, we go from -3 to positive 3 in the domain. That's the farthest left and right it goes. And we do include it because it does touch, so we use a bracket on both sides. Our range goes from negative 4 to positive 3. The farthest down and up it goes. And here we also include our ends. All right, the domain for this one, we're going from negative 3 to positive 3. And we do include our ends. We go from negative 2 to 4 in the y. And again, we include our ends. And then finally, for this one, we go from negative 4 to 3 in our x. We do not include the 3, but we do include the negative 4. And then in our range, we go from negative 5 to positive 5. And because of the open dot on both ends, neither are included. All right, so that is with a finite domain and range on both ends. Now let's talk about if we have one endpoint and forever in one direction. Okay, so we have one endpoint and then we go forever in the other direction. First, we're going to find the location of the endpoint. Again, we're going to use the x-axis for the domain, and you're going to use the y-axis for the range. Now, for the other side, we have an arrow, and that arrow represents that we're going forever in one direction. So we're going to use the infinity symbol. In fact, I'll spell it out here. The infinity symbol to represent forever in one direction. You're always going to use parentheses here because we're never going to include infinity. So you're going to use positive infinity for the right direction, which means it goes forever to the right. You're going to use negative infinity for the left direction. For range, you're going to be using positive infinity if it's going up and negative infinity if it's going down. So let's do some examples of these. So for this first one, our domain goes from 0 and then it goes forever to the right. So from 0 to infinity. We include the 0, we never include the infinity. Now if you were to write infinity to 0, that would be wrong. You have to start from least to greatest when you write domain and range. Your range going to be similar, 0 to infinity, because this arrow is not only going right, it's also going up. If we were to trace this and continue on, it would continue going up forever. Okay, so we go from 0 to infinity in the y as well. Now for this one, our biggest value for domain is negative 3. And we're coming from the negative infinity direction as indicated by the arrow here. We don't include negative infinity, but we do include the negative 3 because we have a solid dot. Now for the range, we're coming from negative infinity because the arrow is pointing down, and we're going up to 2. Again, including that because of the solid dot. All right, for the next one, we're coming from negative infinity on the left side, and we're going to 6, which is included. In the range, the arrow is pointing down. Between up and down, it's going down, so we're going from negative infinity to, you want to say 0 here, but remember, this is a higher value. We want the highest value in the y, so we go to 4 here. For this one, we're starting at negative 4, and we're not including it, and we go to infinity. And then in the range, we're going from negative 4 to infinity as well. And then finally, for the last set of examples, we're going to talk about what happens if we have double arrows. Well, you want to focus on the left and right of the graph, okay? So you're going to focus on the left and the right of the graph. If the arrows point in both directions, then the domain is always negative infinity to positive infinity. For the range, you're going to focus on the up and down of the graph. If the arrows point up and down, then the range is always going to be negative infinity to positive infinity. So let's take a look at some of these. For the first one, the domain, we've got a left arrow and a right arrow. So it goes forever to the left and forever to the right. Now for the range, this arrow is pointing up, but so is this one. So we know we're going up to positive infinity on this side, but the bottom end is going to be 0. Now for this one, our domain is coming from negative infinity, but we stop at -3. For the range, we have a down arrow and we have an up arrow. So negative infinity to positive infinity. Okay, for this one, we have an arrow going to the left, we have an arrow going to the right, so we have negative infinity to positive infinity, or in other words, all real numbers. We also have a down arrow and an up arrow, so our range is also going to be all real numbers, negative infinity to positive infinity. In this graph, it's very much like the first graph that we just did. Our domain goes from left to right, arrows going both directions. But our range bottoms out at -5, because we have 2 arrows that are pointing up. So that takes us to infinity. So let's do a little bit of mixed practice here. So the domain here is, we're going from negative infinity because we have a left-hand arrow, but we don't have a right-hand arrow, so we stop at 4. For the range, we're going from 0, and the arrow is pointing upward, so we've got infinity. For this one, our domain, we have a left arrow and a right arrow, so negative infinity to positive infinity. Our range, we bottom out at 0, and both arrows go up, so we have 0 to infinity. For the next one, our domain, we go from -4, and we don't include it, to infinity, because we have a right-hand arrow. And we go from -4 in the range. Actually, it's tempting to say, because we want to start here, but this is a downward pointing arrow. So since that's a downward pointing arrow, we're actually going to be going from negative infinity, and we're going to be topping out up here. Now you would say don't include the 1 because we have open dots, but in between we include it, so it is getting included in our range. For this one, our domain starts at -5, and our right-hand arrow takes us to infinity. Our range goes from 4, because this is where it bottoms out, because this arrow isn't going up or down, it's just going straight to the right. So we're going from -4 to -2. And then for the final 2 examples, for this one, our domain goes from 1 to infinity, because both arrows are pointing to the right. One arrow is pointing down, one's pointing up, so our range is going to be negative infinity to positive infinity. And then finally, both arrows on each side, so we go left and right, so negative infinity to positive infinity for the domain. The arrows go up, but we bottom out at -2, so -2 to positive infinity. So hopefully at this point you have a good idea of how domain and range work. We've done plenty of examples. Coming up in the next section, we're going to talk about functions and how we notate them, and we'll do a little bit of graphing of the functions as well to get a look at what they look like.